Thanks very much. So my name's Joel. I'm a bit of an imposter here. I spend my day writing C and firmware and whatnot, but I'm here to talk to you about a project I've been working on for a little while. But first, a little bit about myself. So I studied electrical engineering at the low level. I taught myself how to program, and these days I do that as a job, which is pretty fun, I think. I'm a free software person, so I spend lots of time hacking on various open source and free software projects. The project that's recording our conference today is a project that was started by my friend Tim, and I've written a bit of code for that. And so I enjoy playing at all levels of the stack. So like I said, these days I work on producing open source firmware for big machines. But also really little ones, which is what I'm going to talk to you about today, if I can work out my slides. Right, so I like playing with hardware. A little smattering of the various projects. So I've got some Node MCUs up there. We've heard a lot about the ESP8266 today. I enjoy playing with those. FPGAs, sending little balloon payloads up into new space. That was running Chromium on the Beagle board back in 2009 for the very first Chrome port to ARM. And a little bit old PC work, which is where I started writing Python at one laptop per child in Boston back in 2007. So that was a little laptop for children that ran an entire Python stack for the UI and everything. So a little bit of Python heritage there. These days, I play with slightly bigger machines. So to the left there, that's a single socket Power 8. It's a server CPU made by IBM. And so today we're here to talk a little bit about the BMC. But the BMC's job is essentially to enable the big processor. So the big processor is sitting there with a terabyte of RAM and 116 cores. And I've got the little ARM sitting next to it with its half a gig of RAM and its single core. But each has its own job, and they're just as important to make sure the system functions. So what's a BMC, you may find yourself asking. So you have a computer, and these days, to make your computer run, you need another computer. And often that computer itself has another computer inside of it, and it's turtles all the way down. So a BMC is a little embedded Linux computer that sits on the motherboard of your greatest server, or it might be desktop, and provides management and control functionality for that system. So BMC stands for Baseboard Management Controller. Service has them so that when they're sitting in a rack off in a data center, whether that data center is off the middle of Utah or if it's next to your office, you can still sit there and power cycle it. You can type stuff into it. You can hard reboot it when it crashes. If you're installing an operating system that needs a CD drive, you can emulate a CD drive, all these kinds of things. And they generally come with a firmware blob that's made by a BIOS manufacturer. Very similar to maybe like your little router at home that provides you Wi-Fi. It's going to be like an ancient version of Linux with some buggy user space that's full of security holes, unupdatable, and pretty opaque. So to interact with this thing, there's two major ways, really. There'll be the web interface that looked like it was designed in the 80s, and there'll be IPMI, an interface that was designed in the 80s. Right, and so I skipped a slide. So these two ways of interacting with it, they're not the best. We can do better these days. And that was one of the motivations for me and my colleagues who work on firmware and making servers happen, to look at the alternatives. It happened to be that another group of people doing the same thing over at Facebook, and they created this thing called OpenBMC, and that's what we're going to talk to you about today, the idea of a free software BMC. So it runs embedded Linux. We've been over that a few times. Just as an aside, the server software I work on a day-to-day basis, it's all open source. So from that very first instruction that starts executing on your processor, it's all on GitHub. The big kind of black eye to all that was its management processes in next to it, which was running a binary blob created by some BIOS vendor. So the idea of freeing up the rest of the stack was pretty attractive to us. So on the stack, we've got the Linux kernel at the bottom, and sitting on top of that is systemd. So this was a design decision made by the people that are writing the user space. they think that these days a good way to write it in a better Linux system is with systemd. Jury's out. But that's what they chose. And I mean, it does provide a bunch of positive features. The system itself is comprised of a bunch of little daemons that sit there running. And so they might manage different parts of the system. Some examples I put up there. There's the flash, so the thing that stores the BIOS that the main server is going to boot from. The LEDs, LEDs indicate status. Most of these machines have what is called an indicator LED. So you can type some software over here and it will make the light turn on the server so you know which one in the rack you're talking to. Sensors, so fans, temperature, humidity, things like this. And host control, so that's the thing that is equivalent to pressing the on button on the front of your desktop machine. So that group of user space is something that in our project we call Phosphor. That's just a name that's given to kind of encompass those bits of the code. Next to that, we've got some more off-the-shelf common user space components. SSH for doing serial over LAN, so doing remote console. And the Phosphor REST API that we use for interacting with over the network is a Python Rocket framework, a bit of software there. So that's a bit of an overview of the software that's running in user space on the BMC. I spoke in my talk abstract a little bit about being able to bring up a machine just by writing some Python. So this is a little bit of what it looks like. It's probably not the best Python you've ever seen. It's written by firmware guys, but so forgive them. But this is sitting there describing the different states the machine's going to have as it powers on. It also describes where all the different GPIOs are. So where you find your power switch, where you find the LED, where you find the critical power down toggle, things like this. And it's a surprisingly small amount of code, considering how bloated your vendor BMC might be. This is a real small amount of code to describe how the system works. The other thing I didn't mention on the previous slide was that all these user space components interact using dbus. So they sit there on the system bus and provide APIs that the other little programs talk to. And our REST API, the thing we use for interacting with over network, is just exposing all those dbus objects via REST APIs over the network that way. So in theory, you can write some user space code, little daemon, that exposes some dbus interfaces and then interact with that over the network. Whether that might be providing a new way to do updates or a way to scrape some certain information out of the system, it's relatively easy to do. All right, so I spoke a little bit about the web interfaces. This is a quote that one of my colleagues came up with when we were doing design workshop on what we wanted the user interface to look like. So that's what you get if you search for BMC web UI on the internet. Not the pinnacle of web design in 2016. So instead of having a web interface for the first prototype of OpenBMC that we worked on, we used a REST API. So there was no web page you could visit. We did all the bring up and testing using curl. Curl's pretty cumbersome after you've sit there and used your bash history to find that login command for the thousandth time. So you might want to write some Python. So even a C programmer like me can use requests to write some Python to control his server. And so instead of having to go through the hoops of firing up your browser, finding out what the IP is, logging into the web UI, knowing Google what the default password is, how to log into it. Instead, you can write some Python and use a nice little user space program, command line program to interact with it. That's good if you're a developer with one machine in the rack that you're sitting there and testing. And it's also good if you've got an entire rack or an entire data center of them. It's a lot easier to use than clicking on web UIs, and potentially easier to use even than scripting IPMI, for instance. So that's an overview of kind of what we've done. We want to run a modern kernel. We want an up-to-date user space so we can do security fixes. We're going to make it look good, or at least look good to developers. Down the track, there might be web UIs, but for now, it looks good to developers. And make it work well. So instead of tools like IPMI, which unless you've been in the data center environment, you've never heard of, we use SSH for interacting with the console. So SSH to the normal SSH port, and you're logged into your BMC. SSH to a random high port that happens to be 2200, and you get the host console. So a lot more familiarity for sysadmins who may not come from the data center environment, and arguably a lot better tooling. A little aside on the modern kernel. So the reason I'm a little bit sketchy on some of the Python is I spend most of my time doing Linux these days. And one of the things about these BMCs, the system on chip that's used is very, very common, but it's an out-of-tree set of code that some vendor in Taiwan has created. And so it's not the latest kernel versions, it hasn't got security updates, it doesn't follow best practices. The user space APIs it exposes for controlling things are custom to that specific vendor's tree and don't use generic Linux-isms. So I've gone about and done a complete from scratch upstream port of this system on chip to Linux. And so the last version of Linux that got released has about 50% support. By the end of the year, we'll have it completely supported. And that's useful not just for our OpenBMC project. All kinds of other people can come along and do it. There's some guy from Russia who popped up on our mailing list the other day saying, hey, I've created OpenBMC using OpenWRT. And we're using it to run this data center here. And so, yeah, cool, thanks. Not only do I benefit, but also he benefits because now everyone's running some secure, up-to-date code. So a few minutes on the future of where we're going with this one. So the project that I've been working on, it's been a prototype OpenBMC implementation for a machine called Barrel-I. Barrel-I is an open compute spec machine made by Foxconn and Rackspace. And so that's a rack of them. This thing's got 2 Power 8 cores. It's got a AC2400 OpenBMC image on it. And yeah, it's designed for Rackspace's cloud, but it runs a completely open source software stack from the BMC all the way through to the BIOS, all the way through to your Linux install that you've got on top of it, which is pretty cool. So something I want to do personally is support the machine that I have under my desk at home. A bunch of friends have pointed out to me that they've got these ASPEED chips inside their little home servers and whatnot. We don't currently have an image that you could use there, but that's something that could potentially be supported. We're going to do a web interface of some description. There's a bunch of work from different parties involved in making the boot process more secure. So doing trusted boot, so testing the boot as it proceeds. Secure boot, which is cryptographic verification of the next thing you're going to load before you load it. And other security features, locking down the user space so all these daemons can't, they're not all running as root and can't get easy privileged escalation inside the system there. Upstreaming all the things. So this is something I'm passionate about. I spend most of my day job sending code out for initially the kernel. Next will be U-boot, IPMI tool, various other parts of the open source ecosystem that we use. And in the future, there'll be lots more hardware shipping with OpenBMC. There's been products announced by various people, you can Google for it, that describe the machines they're going to build, and these will have OpenBMC in them. So that's pretty cool. So that's all I had in far as structured talk goes. I wasn't sure what my audience was going to be like. If we're going to be all C programmers like myself, probably not, being a Python conference. So I'll open up to the floor for any questions, and we can talk about whatever you want to talk about.
Can we just please, if anybody has a question, I'll run the microphone and we'll put you on the microphone. So any questions?
So, like, you're talking about booting up the server and so on with this. I mean, could you maybe talk a little bit about sort of how this might relate to sort of embedded applications and sort of servers on a lesser scale than servers?
Yeah. So, well, I mean, one of the things I want to do with OpenBMC is just to test my OpenBMC, because when I'm not working from the office, I want to be able to remotely control my OpenBMC with OpenBMC, so I can test builds. And if I crash the target, I can still reboot it using OpenBMC. So yeah, I mean, there's no reason that this has got all the ingredients of being a kind of remote control, remote monitoring application. And that's something that's kind of, once you've got a normal Linux stack on there, that you can put your own software on, it can be whatever you want it to be. You can use it for home automation or battery control or whatever it may be. Yeah, definitely.
And so maybe just as a follow-up, so you would see this as being like maybe on an embedded device, you'd have OpenBMC, and then you'd have the full Linux stack on top of that as well. And so the OpenBMC would give you a very low layer access to some of the capabilities on the board. Is that?
Sorry, could you say that again?
Like, I mean, how would you see it if it's deployed in the server environment? I can see this, but how would you see the architecture working on for a home automation thing or for a distributed device or something like that?
Well, I guess at its core, it's just another little Linux computer, and the software on top of it, it's designed around collecting logs and monitoring of sensors, because that's what a BMC does. You know, it collects crash logs when there's a hardware fault. It makes sure the sensors and the hard drives and the PCI cards are all working. So if you're going to use it for some kind of remote monitoring application, you could leverage all those kind of little parts of the system. To be honest, at least currently, it's not much more than just another embedded Linux system that happens to have some convenient ways of interacting with it and collecting data. Yeah, no worries.
Any more questions?
Just wait for the mic, thanks.
It's more of a curiosity. I've never worked with BMC. But what happens when it crashes?
The BMC itself crashes? Good question. So, I mean, it's relatively fault tolerant in that, you know, you have watchdogs in there. So lots of embedded hardware these days, or lots of embedded hardware full stop, has some kind of hardware watchdog. And so it sits there and it counts down from whatever number, and when it gets to 0, it will hard reboot the machine. And so if the software is active, it'll sit there and kick the watchdog or pat the watchdog and reset it. So the idea is, you know, you might continue to reset it once it gets to some low water point. And so if your software is locked up, it's not going to do that reset operation. It's going to sit there and kick the hardware and restart. So you want your BMC to be resilient to that happening, or so your entire system to happen. You know, when the BMC reboots, you don't want it to take down the host. That would be bad. You want it to be able to recover whatever state it had and things like that. I don't think it's something that's baked into the current implementation of it, but it's definitely something to consider as we kind of evolve the product and it gets more features. I mean, the initial implementation, the version 1 tag that you see in the GitHub repository, that was purely for the Barrelite project's requirements. So, you know, it doesn't have a web UI. It doesn't have lots of the features that you might expect in a full-blown, you know, BMC that you get in your machine you buy from the computer shop kind of thing. It was very specific to the requirements of that project. But yeah, definitely you want it to be able to recover from itself crashing. And that's the problem with having a full Linux computer. Monitoring a Linux computer is who's watching the watches, and you know, how many more computers do you have to have before you're confident that the system's going to stay up.
Another question.
I've got another.
Has any thought been done about harvesting analytics out of all the BMCs, of all the servers, to so many ways, creativity out of it?
Yeah, it's something that I think has lots of potential. You know, using some kind of message passing to sit there and spew out stats to some kind of collection point. If you're running a data center full of these things, that's something you definitely want to be doing. And the advantage of creating a free software project around that is that you could add something like that, where it's sitting there and harvesting data that your application cares about, and you know, whether it's doing a HTTP GET to send it off to a server, or if it's doing a you know, some kind of other message passing kind of infrastructure that you might have in your data center already, or your application. Yeah, come talk to me afterwards. There's more I can say on that afterwards.
With all your hardware and anything, do you have bad sensors that you have to hit and sometimes they just don't return data? And if you do, how are you handling all those? Because I know I do with my OpenBMC implementation. It's a nightmare.
Yeah, I mean, it's a hard problem to solve.
Hardware sucks.
I've not been involved. I've been more in the development side, less in the operations side, so I don't get to see how well our system performs. I can imagine, just like any other system, it would suck. And so, again, that's where I see an open source project being a big advantage. People pop on the mailing list and say, hey, this is a hard problem. How can we solve it? Yeah, there's nothing in there at the moment that does anything particularly tricky or intelligent about fixing. It's hard to deal with sensors, but
Because we have I2C lockup all the time, and we have to write software to then reset the USB hub or reset this or send some power things to that. Like, have you wrote any cool automation around like working around hardware faults for any of?
No.
You don't have to name the IBM product, but any of the quality hardware that you have in your products.
No.
I can tell you the wedge system at Facebook, plenty of little hardware lockups and workarounds we have.
Also, we haven't shipped OpenBMC on anything IBM yet.
Okay.
The Open Compute one, that was a
okay.
Foxconn/Rackspace project that we helped out on.
Yeah.
If you look in the repositories, you'll see work going on for
Yeah.
what you would assume would be an IBM product. But yeah, I mean, that's got a long way to go. The Barrelite, implementation was really just a small type project with a pretty quick deadline on a bit like the wedge was, I assume, from what I heard about it. I'd love to talk more about this.
Yeah, we will tonight.
Yeah,
so
yeah.
I won't waste other people's time.
Simon, a question. So is there any plan, like, say if you've got old Dell Blade servers or old servers, like, would you be able to then put the OpenBMC on those servers?
If Linux supports the chip, then yes. So the most common chip in servers that are currently in production is the ASD2400, the ASP2400. One of my friends, he's got a 2300 in his box. The datasheet, unfortunately, is under NDA. We can't give out the datasheet to everyone, but I can port Linux to it. So if you send one to me, I'll make it work. And generally, the socks are very similar. Like, so the next generation boards that a bunch of the Facebook guys are looking at and other guys and that, the 2500. And all I've done is taken out the ARM 9 core and put in an ARM 11 core. And so literally, it was one line on the device tree to say, this has got a different version of the ARM core, and all the peripherals just worked. So chances are, going back down, it'll be the same deal. You could support an old one, and yeah, jump on. I should have had a link to the mailing list, but github.com/OpenBMC. There's a bunch of links to the mailing list in the IRC channel, and I hang out in there quite regularly at all hours of the night. So jump on and have a chat.
Have we got any more questions? All right. Thank you, Joe. Can I have an applause?
Thanks, everyone.